Hi everyone. So before we start, the product law, very important lesson for expanding. You can see I have a meme here in regards to MC Hammer, who of course gave us such hits as Hammer Time. And I think his life is a parable that we should take note of. He was valued once at the height of his fame at 33 million US dollars, and then had to file for bankruptcy only 10 years later. And you might ask, how can you lose $33 million? And I would like to think that it was things like not understanding the product law and spending time in school, doing well. I don't know him personally, but I'm pretty sure he said that if he did spend more time learning the product law and the difference of perfect squares and things like that, that I'm sure his financial ventures would have been fine. So, let's pay some attention. Sorry to waste a minute of your time. Let's get into what is an important lesson. Hopefully I've hidden myself. I haven't checked this yet, but anyway. So expanding, very similar to what we've done in the past. If we've got two terms, so these are binomial distributions, and we're expanding, we want to multiply everything in one bracket by everything in the other bracket. So you can see here with my arrows, that's a bit of a guide. So in this case, we're going to start by multiplying x times x. I've had some criticism about my x's and multiplied signs, but I hope that you can see the difference between the two. So x times x, then we're going to do x times 5. Oops, not plus. Maybe that's why, because I wrote the wrong things there. Then we're going to have 3 times x and 3 times 5. All right, so x times x is obviously x squared. Just going to leave it spread out for the moment. X times 5 we write as 5x. 3 times x we write as 3x. And 3 times 5 is 15. And that's not all, I hear you say. So we can add these like terms together. So we end up with x squared plus 8x plus 15. So that's fairly tricky, but hopefully you can just use that process over and over. There's no reason to muck any of this up if you just keep using that same format over and over. Okay, let's do one more of these ones. So here we're going to do 2x times x. I'm following the orange arrows at the moment. Plus 2x times negative 6. Plus negative 1 times x. Plus negative 1 times negative 6. Oh, that's going to be a bit messy. So 2x times x is 2x squared. 2x times negative 6 is negative 12x. Negative 1 times x is negative x. And negative 1 times negative 6 is plus 6. Remember, two negatives when we're multiplying become a positive. And again, we can put together our like terms. So 2x squared minus 13x. There's really just a 1 there, 1x, plus 6. Another one, a little bit tricky, this one. So 5x times 3x. Oh, that's not too bad, really. Plus 5x times 7. Plus negative 2 times 3x. Plus negative 2 times 7. Okay, 5x times 3x is 15x squared. Remember, we multiply the numbers together, and then x times x becomes x squared. 7 times 5, 35x. Negative 2 times 3x is negative 6x. And negative 2 times 7 is minus 14. Again, putting our like terms together. So that's going to become 29x and minus 14. Alright, so if we were looking at something like this, where we've got length and width of a rectangle and we're trying to find the area, we can write it out using our brackets, and it's pretty straightforward once we do that. So 2x times x plus 2x times 5 plus 3 times x plus 3 times 5. Sorry, it's so small. So 2x squared plus 10x plus 3x plus 15, which of course becomes 2x squared. This is the area we're talking, plus 13x plus 15. If we were then told that x equals 10, we can actually find out what the area of this shape would be. So 2 bracket 10 squared plus 13 times 10 plus 150. So that's going to be 200 plus 130. Oops, that's just 15 still. Plus 15. And that is going to be 245, well, let's call it meters squared, units squared, whatever it is, 245. That's the area of that shape. You might even be given an area, and then you need to solve for x, which is a little bit trickier. Can show you how to do that in some of the extension work as well. These are kind of some of the trickier questions you might get. If we had something like this where we said x squared plus 2x plus 1 equals that, find a, b, c, and d. So you can see here a equals x, b equals 1, c equals x, and d equals 1. There's a couple more tricky ones there as well. So it's kind of, this is factorizing really, so you're going between the two, but it's giving you a little bit of information there as well. So if you want to look at those in the textbook, go for it.